A very good afternoon to one and all. Myself, Juli Yadav, Assistant Professor in Ajay Kumar Garg Engineering College, Ghaziabad. Today's topic of presentation is implementation of symbol table. So, what does this symbol table is? So, symbol table is an important data structure that creates and maintained by the compiler in order to keep track of semantic of variables, that is, it store the information about the scope and binding information about names, information about instances of various entities such as variable, function, name, classes, objects, etc. As we know, there are basically 6 phases in the compiler design. That is the lexical analysis phase, syntax analysis phase, semantic analysis phase, intermediate code generator, target code, intermediate code generator, code optimization, and the last one is the code generator. So, all these 6 phases are connected with the symbol table. All these 6 phases are connected with the symbol table as well as with the error handling. Why it is connected with the symbol table? Because at every phase somewhere we need to store the value. In some phases we need to fetch the values to calculate the further values for that particular variable. So, the symbol table is basically a data structure. What is data structure? Basically, the data structure we used is used to store the data. So, in this also we are using the symbol table to store the data for the source program. As we know, the source program is written in any of the high level language that can be any Java, Python or many more languages. So, the source code is in that language, which is the input to the lexical analysis phase, that is the first phase. High level language code is written in high level language, which is the input to the lexical analysis phase. Lexical analysis phase produces an output that is the stream of tokens, means it converts the high level the code written in high level language to the code into the stream of tokens, which is the input for the next phase, that is the syntax analysis phase. And syntax analysis phase, what does this do? It converts the stream of tokens into a syntax tree. Then that syntax tree is gone through as the input to the semantic analysis phase, which checks all the grammar rules. If there is any error or if there is any sort of discrepancy, then the that thing has to be checked within the third phase, that is the semantic analysis phase. Then the annotated parse tree is the output for this semantic analysis phase, which is the input for the intermediate code generator that converts the code into the 3 address code or in any of the linear representation or either in the graphical representation, which is the input for the code optimization. What does the code optimization do? Code optimization does the reduction of the 3 address code, means if there is any statement that is written more than 2 times or more than more times, then that code has to be reduced, or some of the some of the operators star, like if there is an star operator which has the which needs the more time for calculating, so instead of using the star it uses the plus symbol. For example, if there is 2 into 2, then instead of this star symbol, how the code optimization can optimize this code, this can convert it into the 2 plus 2, because plus needs lower or we can say it needs less time for the compilation. So, all these phases are connected with the symbol table. Like in the first phase, the lexical analysis phase, what does this do? This convert the source code into the a stream of tokens. So it uses the symbol table so that it can store those tokens with their attributes in the symbol table. In the same way, semantic analysis, syntax analysis phase does the same thing. It stores the information. Semantic analysis phase just check the grammar or the rules of that all the data that is present in the symbol table. Then intermediate code generator fetches the information from the symbol table. I will tell in the later slide how all these phases are connected and why they are connected, why all the phases are connected with the symbol table. So it is built in lexical and syntax analysis phase. Basically the symbol table that is built, that is to be constructed in the two phases, that is the lexical analysis phase and the syntax analysis phase. Beyond this, all the phases uses the data that is stored in the symbol table. So these two phases, that is the lexical analysis phase and the syntax analysis phase, creates the symbol table. Then the information is collected by the analysis phase of the compiler and it is used by the synthesis phase of the compiler to generate a code. What is the analysis phase and the synthesis phase? Analysis phase comprises of three phases, that is the lexical analysis phase, syntax analysis, semantic analysis and the intermediate code generator. So these four phases comes under the analysis phase and the last phases, that is the code optimization and the code generation phases, comes under the synthesis phase. So the analysis phase means the phases that comes under the analysis phase are used to create the symbol table, and the synthesis phase uses those symbol table entries for the further calculation or for the further generation for the target code. So it is used by the compiler to achieve compile time efficiency. So why we are using the symbol table means, what is the need for generating or creating the symbol table? It is used to create the symbol table so that the compile time efficiency can be improved. So these are the phases that uses the that creates the symbol table, and later those symbol table entries are used by the further phases. Like the first phase, that is the lexical analysis phase, whose input is the source program that is written in the high level language. So input for this phase is the source program which is written in high level language. It produces a stream of tokens. So how this phase uses the symbol table? Basically it does not use, it creates new table entries in the table. Means from this phases the table has been start creating. So as if there is a program like A equals to B plus C, if this is the code, then the lexical analysis phase produces A, B, C. These are the tokens, as well as equals to and plus. All these are the tokens and the output for lexical analysis phase. How these tokens are to be stored in the symbol table is like, here are the names of the attribute and here are the attributes. Names like A, B, C. What are these? These are the attributes. A, B, C. These are the attributes and they are the identifiers. What type of attribute it is? It is of the identifier type. Identifier 1, it is identifier 2, identifier 3. In the same way, the table has been created for equals to and plus also. So this is the way how a symbol table has been created. So this is the functionality, or this is how the lexical analysis phase creates the symbol table. Now the next phase is the syntax analysis phase. What does the syntax analysis phase? the input for this phase is the stream of tokens, which is the output for the previous phase. What does it do? It converts those stream of tokens into a parse tree. How? If this is the expression or these are the tokens, then it will creates like equals to, here it is A, here it is plus B and C, right? So, it creates a parse tree of those stream of tokens. So, syntax analysis phase add information regarding attribute type, scope, dimension, line of reference, its use, etc. in the symbol table. It means what? It add the information regarding the attribute type, means what type of attribute is this? What is the scope of this attribute throughout the program? Means if it has the scope for that particular, means it is the local variable or the global variable. All the things, all these informations are to be generated or added by the syntax analysis phase. Its scope throughout the program, its dimensions, line of reference, how use, means if it has been declared in somewhere in the global area, in the local area, then how it can be used in the global or in any other local area. So, all the information about those has to be added by the syntax analysis phase. Now, the next phase is the semantic analysis phase. Basically, it uses available information in the table to check for semantic. Symbol table has been created by lexical analysis phase and the syntax analysis phase. Now, the third phase, which is the semantic analysis phase. For this phase, the input is the parse tree. It produces a annotated parse tree. Annotated parse tree means a parse tree with all the by verifying all the expressions and assignment, or we can say that by checking it whether it is semantically correct or not. So, it uses the information available in the symbol table. Basically, the information that has been stored in the symbol table, it checks, or we can say it is used to verify that expression and assignment whether they are like here A equals to B plus C. This is a parse tree. This is a tree for this particular expression. It checks. Semantic analysis phase check whether this expression is semantically correct or not. If it is not, then it update it accordingly. If it is not correct, then it makes it correct, or it gives an error. That is the other part that I have that I am not going to touch, which comes under the error handling phase. Right. Now, these are the phases in the analysis part, and another one is the intermediate code generator. This phase also use the symbol table. How it uses? It prefers symbol table for knowing how much and what type of runtime is allocated, and table helps in adding temporary variable information. Suppose if the expression is like A equals to B plus C, right? Then we have created, according to the grammar, we have created, suppose we have created a parse tree, and we have also checked whether it is semantically correct or not. So, now we are generating intermediate code. T equals to A, T2 equals to, T equals to B, T2 equals to T1 plus C, T3 equals to T2, T2. So, this is the intermediate code or the 3 address code for this particular expression. So, intermediate code generation refers symbol table for knowing how much and what type of runtime is allocated, and table helps in adding temporary variables. Means suppose if there is a instead of doing this, or instead of doing this, we are assigning a B variable to a temporary variable. What does it takes? If we are doing this, or if we are assigning B to T1 and T2, we are assigning C, and then in T3 we are adding T1 and T2. then what does this do? This increases the compile time. So to reduce the compile time, the intermediate code generation uses the symbol table to check the temporary variables information, whether the information is used or the information that is assigned in the symbol table is correct or not, with respect to their temporary variables. Now now let's move to the synthesis phase that comprises of two phases. First one is the code optimization and the last one is the target code generation. So code optimization, what does it do? It does not do any kind of entry in the symbol table. It just uses the entries that has been stored in the symbol table. So code optimization use information present in the symbol table for machine dependent. What does it mean? Machine dependent means there are two type of optimization. First is the machine independent, another one is the machine independent. Dependent and independent. Machine dependent means when there is a need of machine, if the optimization is done according to the requirement of the machine, then that is the machine dependent optimization. If the optimization is done without the interference or without the machine dependence, then that is the machine independent optimization. But code optimization use information present in the symbol table for machine dependent, means only the machine dependent optimization can uses the information stored in the symbol table. Now the last phase is the target code generation. What does it do? It generates a code by using address information of identifiers present in the table. What does it do? It generates a code that is using address information of identifiers present in the table. Means if there is a address at 100, the name of the identifier is A. What does it do? It checks or it uses the address information of this identifier. Why it uses? Because all the information with respect to this identifier A is stored only in the symbol table. How? Its scope is stored in the symbol table, its value is stored in the symbol table. That's why the code generation phase uses the symbol table to uses the address information of the identifier present in the symbol table. Now let's start with the implementation and operations of the symbol table. Implementation means how we can implement the symbol table, means whether we are how we are organizing the data. We have the data in the data that is scattered. How we organize that data, that is the implementation, means how we organized or how we implement that data in the symbol table. So if a compiler is to handle a small amount of data, then the symbol table can be implemented as an unsorted list. Means if the data is very small, then there is no need of the symbol table or any other ordered list like array, linear list or any other graphical representation list. There is no need of that. If the data is very small, then an unordered list can also be used to store that data in the symbol table, which is easy to code, but it is not only suitable for the large amount of data. If the data or the program is very large, then we need to implement the symbol table organization so that the data can be safely stored at some of the organized place. So these are the ways in which a symbol table can be implemented, and some of the ways are the list, which we can also say the array. The second one is the linked list, third one is the binary search tree, and the last one is the hash table. So what does this list is? Basically, list in this method, an array is used to store name and associated information. It just stored, first thing, it is one of the simplest way to implement the symbol table. List is the one of the simplest way to implement the symbol table, or here we can say instead of list it can be a array, which can be 1D, one dimensional or multi-dimension. Right? As we know that array can be one dimension or multi-dimension. So both or all the dimensions are all the dimensions of array are to be used for storing or for implementing the symbol table. So in this method, an array is used to store name and associated information. Suppose if there are if we have created a symbol table with names and their attributes. So what we do? We store names and associated information. In array, we store names and associated information. Suppose if there is an identifier ID1, right? What it is? It is a name of that particular identifier, right? And what are its in attribute? Means the information related to this identifier is stored in the another column of the symbol table, that is the attribute information. There can be many more entries in the symbol table. So its information is stored in the attribute column. So there is a pointer name available pointer. What it is, a pointer name as available is maintained at the end of all stored record, and new names are added in the order as they arrive. What does it mean? Means there is a pointer. Suppose if the entry in the symbol table is up to ID2, then where the available pointer is, the available pointer points the next location. Next location means if the address of ID1 is 100, address of ID2 is 101, right? Then available pointer, the information about the ID1 is stored at location 100 and ID2 stores at location 101. Then the available pointer points the next location, means 101 is the last entry in the symbol table, then the available pointer presents here. It is at the location of 102. Why it points the next location? Because if there is an entry beyond these entries, then how a compiler or how the entry has to be done? This has to be done only at that place where the the location that pointed by the available pointer. Means if we want to store ID3, then how we store it? Then we check where is the available pointer. If available pointer is at location 102, then we have to store the entry at 102, and all the information regarding that identifier has been stored there. Then the available pointer has to be incremented to the next location, means now it points the next location, that is 103, right? In this way the available pointer works. Now if we want to search a name or to search for a name, we start from the beginning of the list till available pointer. Suppose if we want to search something in the symbol table, then how we will search? Insertion, as I have just told you, is done in the same way. Now how we can search if we want to search any value or information about any variable? Then it has to be searched from the beginning, right? Means from here, from location 100 we are searching. Suppose we want to search ID3, what is the value or what is the information about the ID3? Then how we will search? The searching has been started from the start of the symbol table, means from the location at 100 the searching has to be started, and then it search suppose if we want to search ID4, it search up to available pointer. If it reaches the available pointer, then we can say if ID4, if we are searching the ID4 and we reaches the available pointer, it means what? The available, the entry that we are searching is not available in the symbol table. How we have identified that? Because we have reached the available pointer that points the null entry, means there is no entry at that location where the available pointer is pointing the location, right. So, to search for a name, we start from the beginning of the list till available pointer, and if not found, we get an error, use of the undeclared name, means this error we will get if we search an undeclared variable, means we are searching a variable that we have not declared in the symbol table or we have not declared in the program, right. If we are while we are inserting a new name, we must ensure that it is already present, otherwise an error has occurred, that is multiple defined names. Suppose if we want to insert something, then what we have to do? We have to search. Suppose we want to search, we want to insert ID3, then we have to search whether this ID3 is present in the symbol table or not. If the value for ID3 has been already present in the symbol table, then it gives an error, that is the multiple defined names, means this name has been defined multiple times. So, the insertion is fast, means insertion is fast in this. Why? Because it checks the available pointer, and but lookup is slow for large table. But if we want to search something, then it will be if the table is very large, then it increases the searching time. So, the advantages of this array or link or the list implementation of symbol table is that it takes minimum amount of space. It takes minimum amount of space to implement or to store the information in the symbol table. So, this is all about the array or the list, which is the one type of implementation of the symbol table. Now, next is the linked list. As linked, we can also say linked list as the self-organizing list. Why we are saying linked list as the self-organizing list? Because it organized itself, means if these are the entries ID1, ID2, ID3, right, if ID3 points this and this one points ID3, and if we have deleted the ID3, then these links are self organized, means if we have deleted the ID3, right, so it organizes the links itself. That's why it is known as the self organizing list. So, it is the linked list is better than the previous implementation, that is the list or the array implementation. It is better than that. It how does it is implemented? Like if there is a table, here it is the names and here are the attributes, right, ID1 and the information about it, ID2 and information about ID2, ID3 and information about ID3, ID4 and information about ID4, and the last one, that is the empty. Here the available pointer is present. So, can you please switch on the fan? फैन बहुत ज़्यादा सफोकेटिंग हो रहा है. So here the available pointer is pointing the location where there is no entry, right. So if this shows the start, what does it mean? If the start is here, means the ID 3 has been searched many times, means the value of ID 3 is used many times, that's why the start is here. Suppose there is a link from here to here, it means if we want to search, means this is the highest searching identifier, the next identifier that is searched lesser than this is ID 2, and then this is ID 2, here is the ID 1, ID 2, and here can be the ID 4. So this shows if here is the start symbol, means it means this variable or this identifier has been searched more times, that's why the start points the this, and there is a link that shows the link, means ID 1 has been searched lesser than ID 3, ID 2 has been searched lesser than ID 1, ID 4 has been searched lesser than ID 2. In the same way the link has been organized, right, self organized. How these has been self organized? If instead of ID 3, if we search ID 2 more times, then what does the symbol table available, the start pointer does? It points this ID 2 and it rearranges the links. It rearranges these links according to their search. So this implementation that uses a linked list, a link field is added to each record. So if this is a record and here is the field of the links that defines the links between all the information present in the symbol table. In this, searching of name is done in order pointed by the link of the field. I have just told you how the searching has been done. The searching has been done if the start is from ID 3 and we are searching ID 2, then first it will go to ID 1, then it will come to ID 2, right. In this way the searching has been done. A pointer first is maintained to point to the first record of the symbol table, either it is a start or the first, right, that points the record first record of the symbol table, means from here the symbol table has been started. In this the insertion is fast, in this implementation the insertion is fast, that is O of 1, but lookup is slow for large tables, that is O of n on average, means insertion is fast in both the implementation, that is the array implementation as well as the linked list implementation. Like insertion is fast but searching is slower, or you can say the lookup, that is a function used for searching, is slower than any other implementation. Next one is the binary search tree, that is the another approach to implementing a symbol table, and it is use a binary search tree. But what does a binary search tree is? Means if this one is the root, then the left child is lesser than the value of this root and right child are greater than this. Suppose if here is 3, then its left is less than 3 and right is greater than 3. So in this way another approach has been designed. All names are created as child of the root node that always follow the property of binary search tree, that is left and right child. The left one is smaller than the root and the right one is greater than the root. So in this insertion and lookup are O of log 2n on average, means both insertion as well as lookup uses the same complexity for the average case, right. This is the third implementation. Now the last implementation and the most important and most preferable implementation of symbol table is the hash table. In hashing schemes, two tables are maintained. There are two tables. this one is the hash table and another one is the symbol table, right? Hash table, what does hash table have? Hash table has all the entries that are present in the names of symbol table. If here is x, y, z, then in hash table x, y and z are present, and there is a link that points the symbol table, right? So, and there is a link between these internal attributes, right? So, a hash table is an array with an index range from 0 to table size minus 1, means if this is a hash table, then it starts from 0 to n minus 1, means size of the table minus 1. These entries are pointers pointing to the name of the symbol table. These entries points the name in the symbol table. To search for a name, we use a hash function. If we want to search anything, then we have to use a hash function that will result in an integer between 0 to the hash function. Hash function calculates some value that is the integer value. It returns an integer value that is used for the searching of that particular value, variable or value. Insertion and lookup can be made very fast, means in this the insertion and lookup means searching can be done by O of 1. The advantage is it is quick to search is impossible, and disadvantage is that hashing is complicated to implement. So, basically to generate or to implement a symbol table, this technique has been used, that is the hash table technique has been used because it is the fast way of insertion and the searching. That's why this technique is most preferably used. Thank you so much.